Hello, everyone. Thank you for joining us this evening. I'm Willie Costello, and I'm the AI ethics stream owner here at ACE. And I'm very excited to welcome you to this inaugural session of ACE's AI sustainability stream. Now, for those who don't know, ACE is a global community of machine learning researchers, practitioners, and enthusiasts founded in Toronto, Canada. We do a lot of different things here at ACE, but our mainstay is doing live sessions like this one. And these sessions aim to showcase the latest and greatest in AI and machine learning research and trends as a way of making it easier for everyone to keep up with the best of what's out there. Now, ACE also organizes social events to bring the AI and machine learning community closer together, and we run workshops to help you learn how to translate state-of-the-art research into practical applications. So to learn more about everything we do, please visit our website at ai.science and subscribe to our YouTube channel at ML Explained. Now, tonight, I'm very pleased to welcome Moja Afroughi, a data science who's specialized in sustainable AI solutions. Since 2014, Moja has worked in government agencies, academia, and tech industries, and has developed AI solutions for lots of different applications from clean energy to automotive diagnostics, smart agriculture, and air quality modeling. Now, Moja is here tonight to give us a talk on AI for future sustainability, where he will share some of the ways that AI promises to reshape numerous industries and help us build towards a cleaner, more environmentally conscious future. The format for tonight's session is as follows. We'll kick things off with Moja's talk. He will speak for around 20 minutes uninterrupted. And following that, there will be a Q&A. If you have questions for Moja, you can use the chat in the YouTube video to write those questions in, and I will relay them in the second half of the session. And that's pretty much it. So with that, I'll now turn things over to Moja. Thanks.
Thank you, Willie. So today we're going to talk about AI use cases in industries that directly affect the future of sustainability. These industries are namely energy, transportation, water, and agriculture that can utilize AI to mitigate most important threats to the Earth's ecosystem. We classify these threats into two groups: emissions and wastes. Here, emissions are referred to air pollutants, and they can be in form of gases such as GHG emissions and carbon particulates. Carbon particulates are nanoparticles with a size range from few nanometers to microns. On the right side, you can see aggregated particles formed from hundreds of carbon cores, and they bring all sorts of problems to the environment and public health. On the other hand, we consider waste as a non-airborne component, such as landfill, chemical waste, and water waste that could be also harmful to the environment. So we know that air pollutants and carbon emissions by far are the most dangerous byproducts of economic growth. So the main idea behind sustainability becomes digitalizing and transforming industries in a way to help with the decarbonization process. And this has not been ever easier than before by accessing the vast amount of data through IoT, sensors, and automation. If so, we can see up to 4% of the GHG emissions reduction in energy and transportation sectors, and up to 0.5% cut in water and agriculture industries. Digitalizing water and agriculture industries can also help preserving ecosystems, natural resources, and biodiversity. Moving on to energy industries, the main challenges are optimizing fossil fuel power supplies, transition to renewable energies, and optimizing distributed grid systems to prevent surplus energy production. We know that we are going to rely on fossil fuels for power generation in the next decade, or at least a mix of fossil fuel and renewable energy supplies. Renewable energies have zero emissions, so we need to have a system of measurements for assessing environmental effect of fossil fuel usage and any regulation that we impose to optimize the energy production and distribution process. And that's where we can get help from emission inventory development and ambient air quality monitoring. Emission inventories try to predict direct emissions of air pollutants from the source, such as power plant, and is the main tool for imposing regulatory acts, while air quality modeling is more related to public awareness and public health effects, as it takes into account the mixing and dispersion of emissions in environment and tries to predict spatial and temporal behaviors of pollutants in microenvironments such as cities. So the AI role becomes to adapt new IoT and more advanced sensors with higher precision to first accurately develop regional and seasonal emission inventories by predicting temporal emission factors, which are in format of gram of emission per unit energy produced. And second, accurately model and predict stochastic behavior of pollutants, which are influenced by those stationary emissions such as power plants, plus mobile emissions such as traffic, weather conditions, topology of land, and so on. One of the studies that we did on modeling air pollutants and specifically particulates was to develop noise sensors for predicting nanoparticles concentrations along highways based on several parameters, including traffic volume, speed, weather, and GIS data. The benefit here is that first, noise sensors are cheaper and easier to maintain, so they can be used more widespread and for longer period of times, allowing better understanding of temporal nanoparticles behaviors in the longer period of time. Second, noise and nanoparticles come from the same source, and that's traffic. So there's already a good correlation between noise and nanoparticles, which is around 70% if both of them are downwind the traffic. So now that we know how to measure the efficiency of a power supply based on its emissions, the next step would be optimizing the process. For renewable energies such as solar, wind, tides, and waves, we have zero net emissions, but we still need to reduce downtime caused by external disruptions such as solar flares, hurricanes, and earthquakes. And that's where AI can help detecting early faults for predictive maintenance. And what about fossil fuel energy supplies? There are still ways AI can help, such as IoT for pipeline maintenance and management and improving combustion and chemical processes. Now I'm going to briefly go over one of the projects we did for Natural Resource Canada to optimize the combustion process of natural gas power supplies for zero CO2 emissions. The idea here is to thermally break methane, which is the primary component of natural gas, into hydrogen gas and solid carbon, so that hydrogen can be used as the carbon-free, clean source of fuel, and solid carbon can be collected directly without even getting exposed to the environment. I'm going to skip over the combustion and mechanical constraints here and talk about optimization challenges and AI use case. For optimization, for the optimization process, we had a small scale power system that you can see on the right side. And we had over 20 sensors monitoring temperature, pressure, flow rate, and chemical components in the combustion chamber and along the pipelines, plus more than 20 sensors for monitoring different exhaust gas components and quality of solid carbon particles. So the problem turned into a big optimization process. What is the ideal condition of system? The first 20 sensors that I mentioned, and how can we minimize CO2 emissions while producing the most amount of solid carbons? Another aspect of using AI in energy industry is optimization of grid distribution, so that surplus energy is reduced, and ultimately the associated emissions are reduced. We know that electricity is served in a network of localized and interprovincial grids, and the delivery plan heavily depends on forecasting future demands. So the key component here is to accurately predict short and long-term pattern of energy consumption by taking into account the seasonal and weather patterns. And this has been enabled by IoT for monitoring energy use. Moving on to the next, industry transportation. The main sustainability challenges in transportation are related to supply chain and mobility of cargo, fleet, and of course, people. AI has shown tremendous potential to transform this industry for better good by introducing autonomous vehicles, autonomous delivery, supply chain optimization, fleet management, and predictive maintenance. The environmental benefits are huge, including achieving zero emissions from electric cars and optimizing traffic flow. From the economical perspective, AI can help reducing downtime in supply chain by accurately predicting the demand, optimizing the logistics, and forecasting future maintenance needs. As a case study, I'm going to quickly go over one of the projects we did for fleet management and predictive maintenance. Here we want to detect the idling episodes of individual vehicles. By doing so, we are able to track drivers' input behavior and build a messaging system for future correction or warning. We use GPS and OBD2 scanners to capture real-time signals from location, engine, such as throttle input, and speed. And once the speed is zero, vehicle is stationary, and we have no throttle input, we can say that the vehicle is in idling state, but the engine is still running. And later, based on the duration of idling speed, we can accurately predict the emission associated with this unwanted state. What about predictive maintenance? We take similar approach of ingesting real-time signal data, but this time from all the components, such as engine, transmission, battery, and brakes. Then we use AI algorithms to look for anomalies or harmful patterns in signals. In the agriculture sector, we have different challenges. We want to meet the growing demand of food by increasing crop yield. We want to reduce cost and overuse of labor, water, fertilizer, pesticides, and fossil fuels. And eventually, we want to protect our natural sources, such as forests. And the key AI contribution here becomes into two different groups. First is smart agriculture, second, precision agriculture. For the smart agriculture, we have AI robotics and task automation, such as autonomous tractors. We have land use planning and management to protect natural sources. And for precision agriculture, we have aerial imaging and field sensors to monitor temperature, moisture, and soil condition. And we also have monitoring weather condition, crop health, pests for required actions. Here I'm going to present to you one of the case studies that we did, and it's about aerial image processing for precision agriculture. We used multi-channel cameras, hyperspectral cameras, and we mount them on the drones. We flew the drone over some agricultural fields, and we wanted to run some image processing for crop count, monitoring and identification of pests and plant disease, identifying a specific location for use of pesticides, recommending exact volume needed, and eventually reducing chemical spray. Water management. Some of the challenges in water management are meeting the global demand for fresh water, reducing water wastage and electricity consumption by water sectors, and how AI can help here. AI can help for better prediction of water demand by tracking industrial and residential water use. AI can help with the predictive maintenance of water infrastructure, such as advanced and new IoT for pipes, water leakage detection and management, and also we want to use AI for optimizing wastewater treatment and desalinations. Thank you very much. That was our short, brief introductory about AI use cases for future sustainability. I'm going to pass it to Willie.
Yeah, thanks, Moja. That was a great overview of all these different ways in which AI has these applications for sustainability concerns. So there's a lot to dig into there, a lot of different industries and applications. But I thought I'd kick off the question period with more of a general question, taking a step back now and just thinking about AI and sustainability in general. Because you've shown us, all of these different ways in which AI is going to transform sustainability applications, or is already transforming these industries. But AI is transforming everything, and regardless of the industry, everyone's saying that AI is going to transform everything, even if they're not related to sustainability. So AI is going to transform advertising. AI is going to transform finance. So I'm curious, just to kind of kick things off, to hear your thoughts about, what are the specific qualities that AI has that makes it particularly well suited to sustainability applications. So, for example, you might think, the fact that we can do time series analysis makes AI particularly well suited to financial applications, and especially, stock market applications. So, what about AI in particular makes it have this promise for sustainability related issues and industries?
That's a very good question. So, as we have as we have seen some advances in AI and new machine learning techniques to sort of work with time series signal data, we can utilize these models also for sustainability cases. So what we usually do for sustainability, we're looking at trends. We want to understand the short and long-term behaviors of climate change. So these could be in the format of air quality, could be in the format of energy consumption pattern, and could be in the format of change of landscape for agriculture. So the weather models that we utilize to sort of take into account the seasonal pattern, the temporal pattern, and taking also into account other parameters, we can have better understanding of what's going on. We can have better understanding of underlying mechanism, and eventually we can have better optimization algorithms to help with the sustainability.
Cool. So it really does come down to like the seasonality or the cyclical nature of these patterns and processes that we're modeling, and the fact that AI helps us better predict those, model those, and thus adjust for those dynamically as they change.
Correct.
Nice. So if I can ask like just a kind of flip side question to this, do you think that sustainability poses any unique challenges for AI? Are there any aspects of these issues that make it difficult, extra difficult, to get these methods to work?
Yeah, there's some cases that still are not properly solved. Let's say you want to have some we want to build some algorithms to accurately predict the timing of earthquake. So the underlying mechanism depends on so many parameters here. And in order to properly detect such a short episode of time in different seasons, you need to deeply look into all the historical patterns of all the parameters that you can associate with the earthquake. So the challenges, some of the challenges are still the same, such as adequately predict timing of earthquake, but most of the challenges are getting solved better because we now have more robust algorithms. We can now have a vast amount of data that we are getting, and with the advances in building more robust and precise sensors.
Right. So it sounds like one of the big challenges is just that the phenomena that we're trying to model are very complicated, especially when we're dealing with geological phenomena. But I think, as you point out, AI maybe gives us our best shot at modeling these phenomena insofar as we can take in more data than ever before and use more advanced modeling techniques. Just out of curiosity, is data quality an issue in your opinion? I mean, I know this will depend on the use case, but how is data quality in general for the modeling that we're trying to do?
So the data quality issue related to the sensor data that we receive is mostly around the sampling rate. So let's say you're collecting data from a phenomena or from a parameter every second. So then your sampling rate becomes 1 hertz. But the dynamic behind all of the changes in these patterns, there might be even below millisecond. So you need to have better sensors with higher sampling rates to better correlate those. And right now in industry, we don't even have 1 hertz sampling rate. The sampling rate in industry is like maybe a quarter of hertz, 1/8 of hertz, and that's not close to enough to tackle some of the issues. Let's say you're building a predictive maintenance model, and you want to look into signal data that you're getting from different car components. If the sampling rate is not fast enough for you to collect all the signals, you cannot say anything for sure around the cause of the effect. You might be able to capture the effect if you're lucky with your low sampling rate, but you need higher sampling rate to detect those very dynamic patterns.
Yeah, that makes a lot of sense. Okay, we have a question from the audience. It's another kind of general question. And this audience member is asking, where do you see the most jobs in the AI sustainability space? So the audience member specifically asks, do you see them in consulting or startups or government? I'd also be interested if you think certain industries are booming more than others. But what do you know? What do you think about jobs and sustainability in AI?
I think startups are gonna have a boost in sustainability. Two sectors are they're showing great potentials here. One of them is agriculture, which is under-discovered. So right now we're at the beginning of autonomous and smart agricultures. So that field is open. The other field that is open to startups is, of course, autonomous vehicles and autonomous delivery. So the biggest market gain is going to be in transportation and agriculture.
Well, thanks. And I'm sure our audience member will appreciate that. Um, so let's now dive a bit deeper into some of the specific topics you talked about. And I have some questions for each of the topics. So you talked about energy, you talked about transportation, agriculture, and water management. And let me start with a question about the energy sector, because so a number of the innovations that you discussed were ways in which AI can help optimize emissions or air quality control, power usage, things like that. And these optimizations will, of course, have a huge effect on pollution levels, like bring pollution down, and that'll have a beneficial effect on the environment, and that's all great. Um, but I'm wondering how you think these improvements compare to just the benefits of more drastic changes to our energy consumption practices, like transitioning away from fossil fuels entirely to renewable sources of energy. And part of what I'm interested in here is just the comparison, like how, if you know, how much do these optimization improvements, how much of an improvement did they make in comparison to, a more radical change? And more broadly, I'm just kind of interested in how you think AI may or may not help accelerate the more widespread usage of renewable forms of energy.
So in the case of renewable energies, we're not gonna fully transit to to that industry for at least a decade. So we're gonna have a mix of um, fossil fuel energy supplies with renewable energies, and in order to have a smooth transition, you want to build some reliable infrastructures, and you want to be ready for that. And the AI role here is to accelerate this transition. So if we can have a better, a smoother, uh, uh, and a more solid transition to renewable energies with the help of AI, it's going to be faster. But for now, we're going to rely on fossil fuels for the main source of energy. Um, but the AI role is getting bigger and bigger every day in this sector, um, especially with the integrated sensors that you can have. So the main issue with this old-fashioned fossil fuel supply energies is that it's so hard to integrate some sort of sensors into them. So hard to understand the system entirely. It's a chemical combustion process, and distribution is hard. Controlling the process is hard. So um, unwillingly, you have to sacrifice some of the benefits here by just using fossil fuels. But for now, we have to do it.
But are you saying that with renewable forms of energy, it'll actually be easier to implement certain sensors and have a more data-driven approach to energy?
Yeah, for sure, for sure. So let's say you have a source of energy supply which is working with coal or natural gas. And in order to fully control that process, sometimes you're relying on mechanical sensors. So, and the mechanical sensors, you got to do post-processing on those. You don't have real-time monitoring or processing on mechanical sensors. Let's say you have a valve, you have like a pressure gauge. That pressure gauge doesn't send signal anywhere. You got to read it. You need to an engineer to continuously check on those. But with renewable energies, everything is electricity. So anything can have a component of sensor into it.
That's really cool. I never realized that. I never thought about that. But yeah, that definitely is a real advantage that AI will have in that space. In addition, we just had a note from one of our audience members who also wanted to add that sources like wind and solar energy are intermittent, so AI is going to have a role there in predicting and making those more, efficient and affordable. And I think that relates to, a lot of what you were talking about in terms of distribution grid and other sort of timing issues. Yeah.
For sure, for sure. The more control you have on the process, the better you can optimize the process. So with renewable energies and with grid system, you know how to monitor it already. But with renewable energy, it's easier to monitor and maintain it and to detect failures or any leakage. But with fossil fuel supply energies, you're still relying on engineering reports. So it's going to be harder to optimize the entire process. And sometimes you have some constraint that you cannot optimize it more than that. So let's say the flow rate on a pipe cannot be higher than that. So you cannot optimize that.
Mm-hmm. Yeah, that makes a lot of sense. Well, now let's maybe now transition to agriculture. So this is another area, as you showed, like AI promises to really innovate and make all these um, new transformations of the industry. Here, I guess I'll admit that I'm a little more skeptical going in. So one thing that I think of is just in contrast to energy, we're not like transitioning from just like fossil fuels to renewables. It seems like the difference between industrial agriculture and AI powered agriculture is much more kind of gradual and continuous. And one of the things that I think we've seen in the last century with the move towards industrial agriculture is that although industrial agriculture has definitely transformed farming, it's done that in ways that have, in many respects, been negative towards the environment. So if you think, for example, of monoculture farming or GMO crops or factory farming, these are innovations that have really transformed the food and agriculture industry and have had certain benefits, but have also had a lot of harmful effects on the environment. So now thinking about AI-powered agriculture, how do you see that as being different from industrial agriculture? And how might it help us chart out a different future for our farming practices insofar as they relate to the environment?
Yeah, that's a good question. So for the smart agriculture, uh, again, you're taking control of what's going on in the farm with adding sensors, either field sensors or you're doing some aerial imaging. But the real benefit of AI here comes in a larger scale agriculture, because with a small scale agriculture, the financial expenses are still not justified. Um, the benefits are still the same. You're still gaining benefit by, let's say, using less pesticides in your field, using less water resources or fertilizer. So you're definitely cutting some costs here. But to implement those infrastructures in a small field is not going to be so financially justifiable.
So the main use is going to be for these large scale farming operations. Um,
Exactly.
at the same time, I mean, I think these large scale farming operations are some of the ones that, have made environmentalists the most worried, insofar as, you're planting a single crop in a huge swath of area or, rotating or just slash and burning. And so do you think there are any ways in which, with the help of AI, we can really transform how we're even approaching large scale farming? Or are the changes kind of more incremental in getting us to, use pesticides more precisely or manage water usage, things like that?
For yeah, for larger scale agriculture, your land use planning is the most beneficial use of AI. So you want to you want to make sure which part of the lands are more suitable with what type of crop. So that's the beneficial. That's a good benefit of it, and it's again justified for larger scale agriculture. But for a small scale, you can implement some precision agriculture methods. So instead of flying drones over your field, you can just have landfill sensors to just track the moisture, soil state, or temperature. And with that, with those even minimal inputs, you still can have better optimization than traditional agriculture.
Yeah, that makes sense.
And to add to that, for there are actually some countries that they're doing larger scale agriculture instead of so the government is taking control of all the agriculture process, like Ukraine, and there is no like small field owned by like there are no individual farmers. They all work for government. And why is that becoming a good idea for them? Because now they can fly drones over a vast area of land rather than just a small area, and that would cost them so much cost. And then you have autonomous tractors, so it's gonna it is way better than just applying those for a small scale agriculture. Still, there's some potentials that you can do. You can actually manage regional fields with one control unit of smart agriculture. So if you think of many small fields as a batch, you can actually build precision agriculture or autonomous agriculture for those units in the batch. But then you gotta talk to the owners, right? Because they gotta agree on that. So it's not gonna be like a one shot solution.
Yeah, so it sounds like one of the benefits here is just maybe greater coordination across like larger and larger pieces of land, and and that of course has these benefits of how we're managing the land.
Yeah.
Okay, if I can ask you about water management now, because I mean I think you're absolutely right to bring up this issue. It's hugely important, and you discussed a number of interesting ways in which AI can help us achieve this goal of clean water for everyone. One of my thoughts here was that some of these AI powered solutions that you mentioned, like trackers or sensors, IoT, even just wastewater treatment plants. These are solutions that require a lot of technical infrastructure to be in place, right? And this might not be a problem in more technologically developed areas like metropolitan cities and whatnot. But many of the areas of the world that are most in need of clean water are precisely areas that are not as technologically developed. And yeah, so I was just wondering if you had any thoughts on how AI will assist areas like these, or should we think that the priority in these cases should be first kind of building up this necessary technical infrastructure, whether or not it's AI powered?
So for the underdeveloped countries and for the water management in those countries, you can use AI actually for water distribution optimization. So that's the main area that you can work on. But for applying new IoT or sensors into the pipes, let's say you want to detect some leakage in the pipes, right? You want to detect some leakage. If you don't have the right infrastructure, you can you cannot actually monitor anything. You still need to rely on mechanical ways of digging the pipe and checking for leakage. So still the infrastructure is not financially justified even for developed countries. It is justified for oil pipelines, because if the oil has a leakage, if the pipeline has a leakage, um, maybe a day worth of oil is gonna go to the waste now, right? So what they have right now is they have some robots uh, that crawls into the pipe and has a scanner on them, some infrared scanner on them, and look for any corrosion and monitor these corrosion along the pipe. But again, it's justified for oil pipelines, but not water pipelines.
Yeah, that was an interesting point you made about water distribution. I hadn't thought of that, but it makes a lot of sense. Yeah.
Yeah.
Yeah. Do you see this as like a particularly important area in the next 10 years? I mean, you were saying that agriculture and transportation were the areas that you thought were kind of most going to be in demand in the next 10 years. But are there a lot of companies working on these water problems as well? Do you know?
Not that I'm aware. Well, there are companies working on building smart infrastructure for pipeline monitoring, but not in the large scale. Because uh, having those solutions needs governmental approval, and that's the first constraint that you have right now. But for agriculture and transportation, you can build your own startup, and you can grow your own startup in those fields, and there's no constraint on that.
Yeah, that's a good point to keep in mind. Just, how much freedom you have to innovate kind of within these political municipal structures. So yeah, as you're pointing out, water is just much more whatever, the property of the government, for better or worse, and that actually kind of limits what just anyone can do within that space. All right. So to kind of close things off, I'll ask you a question about transportation, the last industry that you discussed. And so you talked a lot about how autonomous vehicles and autonomous delivery are going to transform the transportation industry, and at the same time reduce emissions and traffic. But I think when a lot of people hear about autonomous vehicles, the first place their mind goes to is the resulting loss of jobs. And we know that trucking and other transport jobs are a huge sector that employ a lot of people. So I was just wanting to hear your opinion on this. Do you think this is a case where sustainability considerations might just be in tension with labor considerations, or is there some kind of happy medium here that can be reached?
So no, unfortunately, it's not going to be. It's not going to have a happy outcome. So studies show that all of those industries are going to suffer from job loss. But the contribution of AI in the growth of global GDP is going to compensate for that. So we're going to see a shift of labor need in those industries to other industries overall. But also we're going to see a shift from labor jobs to managerial and professional jobs in transportation and forestry, fishing, and agricultural jobs.
Yeah, that makes a lot of sense. I'm also wondering, like, do you know I assume we're still many years away from fully autonomous transport vehicles. Um, so do you know like how long we might be seeing just kind of AI assisted transport rather than fully autonomous vehicles? Because I assume, I mean, some of the examples you even discussed were ways in which AI is being used to, reduce idling time, or in other ways, I'm guessing making the labor of driving and delivery easier
Yeah,
for the humans who are doing it still.
yeah. So I would say for the transportation fee, for the transportation field, because of all the safety issues and hazard concerns, we're not going to see fully autonomous vehicles as like self-driving cars just to transport people. But for fleet uh, and autonomous delivery, we're going to see a huge trend over there. So because that makes sense. That makes more sense if you have smaller vehicles just to deliver packages, and they have less safety and hazard issues. Um, Government would approve those faster, and they're going to be implemented faster. For autonomous vehicles, um, the thing is, if you want to have a reliable autonomous system of vehicles, you got to have every vehicle automated. And we're not there yet. We're doing some work to sort of make gasoline or diesel engine vehicles smarter by taking a look at their signals and doing some sort of predictive maintenance, fleet management, and these are going to be real-time monitoring, but these are not real-time autonomous driving. So for the monitoring and tracking drivers' behavior, or even condition of the car from every component aspects, we are seeing a good advances of AI. But for fully autonomous, I don't think in the near future, at least in the next decade, we're going to see that fully implemented.
Yeah, I think you're definitely right, and I mean, I think you're also definitely right that we're going to see these moves towards automation first in fleet and delivery before just ordinary vehicles. I was curious, why do you think fleet and delivery are safer, and thus will be approved faster? I mean, these are vehicles driving on the same roads, right?
The yeah, yeah, they're kind of driving in the same road, but for delivery, my point of talk was about like small deliveries. So we have small delivery vehicles that they can't even go to the sidewalk. So for those, there is no problem. They're like small robots that just do the job for you instead of
Right, so they can't run you over.
they
So
cannot. Yeah,
there's less of a safety risk there. Yeah.
if you don't break them, they don't break you. But for the fleet management, still we're not fully ready for autonomous fleet. So the first phase is going to be how to monitor them, how to control them, and how to detect harmful patterns that can lead to accident. And then if we are fully confident on those stages, we're gonna, shift to the fully autonomous delivery. But that again, it's not gonna happen in near future if they're gonna be in the same road of people driving.
Yeah, that makes a lot of sense. Yeah. So that brings us to the end of the questions that I had. I thought maybe just as one final question to you, and something more speculative and fun. just wondering, is there a particular kind of innovation within the AI sustainability space that you are most looking forward to happening, or most hopeful to see, say, in the next 10 years?
I think we know what's gonna happen, kind of. But the most exciting part is going to be for sure autonomous vehicles. The other exciting part for me is smart agriculture. And again, you have autonomous trucks and tractors. So anything that has an element of automation is pretty exciting to me.
Yeah, definitely. All right, then. Well, that brings us to the end of this session. Thank you first, Moja, for this great talk and this great discussion. I learned a ton, and I'm very excited about all the things you've had to share. Thanks also to the people in the audience who wrote in with questions and comments. If you want to learn more about this topic or any topic in AI and machine learning, remember to visit ACE's website at ai.science. Subscribe to your YouTube channel, and we hope to see you again. Good night, everybody.
Good night.